back in time.
Not yet. I don't know if she is going to connect. Because if you read the email, she had some issue. Let's wait a couple of minutes and then we can start.
I'm also wondering if I should close the door or not.
We tried and
Okay, we'll try because it's
from every direction.
Yep.
It's arriving from everywhere. Okay. It's just for test of for people that is remotely. Can you hear me properly? Please reply on the chat. Okay. Yeah, it looks like it's working. Maybe I was not too close to the mic. Yeah. Yeah, just one more minute to see if my co-chair will join. Otherwise, I will start. Okay, I think we can start. Welcome everybody. We are in the benchmarking methodology working group session. If this is not the session you are looking for, you have to go in another room. Yeah, I'm Giuseppe Fioccola, one of the chairmen of this group. And if you are not subscriber to the BMWG mailing list and would like to be, just visit the website on the slides and please join the mailing list. Okay, these are the not well page that I guess you are familiar with this. So by participating in the IETF meetings, you agree to follow the IETF policies, procedures, and processes. So if you are aware of some IETF contributions covered by patents or patent applications, you must disclose it. As a participant in an IETF or any IETF activity, you acknowledge that written audio video material may be made public, and as a participant or attendee you agree to work respectively with other participants as well. We also have the note really well, so it means that ITF meetings, virtual meetings and mailing lists are intended for professional cooperation and networking. The IETF want to maintain an environment in which people of many different backgrounds and identities are treated at the same level with dignity, decency, and respect. And if you believe that one of these conditions are not met, there is, you can notice that you are encouraged to raise your concern. Some meeting tips. So make sure to sign into the session via the data tracker or the QR code. For in-person participants, join the mic queue if you want to participate and make comments, and keep your audio and video off for the on-site version. For remote, make sure that your audio and video are off unless you are presenting or sharing, of course. And we need note taker, so everyone is welcome. So, okay, thank you, Paolo, to volunteer. In any case, you can find the note-taking tool on the client, on the data tracker, and you can help with the notes. Okay, let's move to the agenda. We have 4 working group drafts to update. The first one on multiple loss ratio search. The second one on Young Data Model for network tester management, including the hackathon part, the hackathon result presentation. Then we have the consideration for benchmarking network performance in contained infrastructure from Mingong. And then the recently adopted document on benchmarking methodology for segment routing. Then we will move to the proposals. So the first document is the characterization and benchmarking for power in network devices, the SRB6 service benchmarking guideline, and then we moved with benchmarking methodologies for source address validation. Then we also have a presentations about benchmarking IoT devices from Anna. This presentation for now is not related to a draft, but it may be a document in the future. An update about the status of the document. As usual, reviewers are needed, so your work is adopted, completed, and published when the participant of the working group read, review, and share the comments on the list. So it's a two-way street. We are 2 documents that can be considered in preparation for the working group last call are multiple loss ratio search and the Young Data Model for network tester management that are quite stable. Maybe the author will give some updates about the current status and what they think about. We have ongoing proposals that have been recently adopted about the consideration for benchmarking network performance in container infrastructure and the benchmarking for segment routing. Some proposals are coming. We already discussed the last IETF, the benchmarking for power in network devices. DSRv6 service benchmarking guideline, and a new work that is the benchmarking methodology for source address validation. Regarding the activity, lately we have the benchmarking methodology for stateful NATIC SIPs gateways in RFC Editor Q. So it will be published soon, hopefully. A new working group adopted, a new working group document adopted. So the benchmarking methodology for segment routing. And I think that's all. We plan to update the milestone according to what we will discuss today and after the meeting relating to the working group plus call of some documents. So I think we can start now with the first presenter. Maciek or Bratko?
Yep, I'm here, and I will be presenting on behalf of both of us.
Do you want the control of the slides?
If you don't mind, Giuseppe, could you drive the slides?
Yeah, sure, of course.
Thank you.
Go ahead.
I don't see anything shared.
Can you see the slide?
I don't see the slides. Anybody else sees the slides? Who is remote?
In the room, we can see the slides.
Okay. Why don't I see the slides on my... Ah, here we go. Sorry.
Okay.
I guess the screen was not adjusting. Thank you, Giuseppe. And hi, everyone. Welcome. So I will be presenting on behalf of Radko and myself on the specific updates for the 07 draft. Next slide, please. So unfortunately, we missed the submission deadline. So we posted this past submission after the reopening on just on Sunday morning, this UK time, or midnight Saturday. And that's because we took a bit of the ambitious task to address any and all comments. Firstly, audio check. Can you hear me okay?
Yeah, we can hear you. Yeah, a little bit, if you can speak a little bit high.
Louder?
Yeah.
Or slower? Okay. I'll try to do louder. So we took an ambitious task to address all the comments we received from the working group in meetings and on the mailing list, going back to the very original version of the draft 01 from 2019. And focusing specifically on making the MLR search specification more approachable, readable, and clear, and specifically focusing on the being very clear with the terms and definitions and the non-formal definitions, and specific references to the associated past BMWG RFCs. So namely, RFC 1242, 2285, and 2544. And we're also making references to the TSP 009 ETSI document focusing on NFV. So that's really what took us a bit longer, and we believe we did really the best we could. We believe the draft is now quite well written and clear in our view, so in author's view. And we believe we addressed all the comments ever raised in the working group, and we believe that it is ready for the last call. Next slide. So, what I would like to cover during this few slides is just the highlights on the content of the draft, starting with problems, looking at the specification areas, and then coming back to the work status. Next slide, please. So we have one of the big comments we got very early on is to clearly articulate what problems we are addressing and why this work is required to amend the content of the previous RFCs, including RFC 2544. So identify those 5 problems, and I think they came also from the discussion with in the room, on the mailing list, and also in the corridors or chat rooms. So we believe that all of those 5 are recognized by the working group. And so going quickly through them, make the search duration shorter by finding sooner the interesting region. Recognize the fact that focusing on the software networking, we do have DUTs, so the software networking applications that share resources within the SUT. So instead of focusing on a single throughput characteristics or attribute or quantity, look at the spectrum, performance spectrum, and then go after what we believe is de facto best practices in the industry. Make sure that the software networking benchmarking results are repeatable and comparable between the labs and between different implementations of the test gear. Recognize the fact that apart from the zero frame loss, people are also quite often measuring the throughput with non-zero loss. And then because we are repeating trials at the same load due to sometimes the need, and also we're searching for multiple goals, we want to be sure that the methodology is consistently and deterministically handles the inconsistent trial results. So these are the 5 problems we are after, and we believe that the methodology proposed and specification does address all of them. Next slide. So I'll quickly go through the specification that basically consists of a number of term definitions and existing and new or amended, and then finishing with compliance or specification compliance aspects. So these 3 SUT, DUT trial, they've been defined already in RFC 2285 and 2544. So they just call out that we're using those definitions without any deviations whatsoever. Next slide. Now, the next 2 slides talk about trial terms, and here we're not necessarily redefining those terms, but we are further, we are much more specific about what they mean in the context of benchmarking software networking applications. So the trial duration, trial load, these are intended duration and intended load as configured by the operator. We then deal with the number of composite metrics or quantities. In this case, trial input is the composite of the trial duration, trial load, and traffic profile includes other aspects related to the load, like frame sizes, burst profiles, and such. Next slide. Now, because of the problem space we're addressing, we want to be specific about things like ratios, rates, and so on, and we want to have them for them to be formally defined, as we are finding definitions in other documents not specific enough, at least for the use cases we are after. So here we have a number of trial terms. Trial forwarding ratio, loss ratio, and forwarding rate. They're related basically to the amount of frames forwarded versus lost, and versus expected to be forwarded. The trial effective duration is it's really by default equal to trial duration, but there are some discussion points that are covered in the draft when that is not the case. And then the trial output and trial result is basically a composite values of the ones listed above. Next slide. So in terms of goals, one of the aspects we find hard to articulate clearly and using a formal language is, as we are dealing with multiple goals, like for example the loss ratios, And as we are dealing with the performance spectrum, we wanted to make sure that the attributes or the quantities that govern those are very well defined. So hence, there is a number of different goal quantities that are now defined in the draft, and we're using those goal quantities to actually illustrate, for example, full compatibility, unquestioned, unconditional compatibility with RFC 2544 and also with TST009 NFV testing, and that will be covered in about 2 or 3 slides. So we have the goal final trial duration, so equivalent of RFC 2544 trial duration, which is, as the recommended, 60 seconds. The goal duration sum, when we are repeating trials at the same load, we need to track the duration sum, and there are some formulas governing that. And then there's the loss ratio and exceed ratio, which govern basically what the goal, what the attributes of the specific goal are if we are going after multiple goals. As the name of the draft and the specification says, it's a multiple loss ratio search. So we're searching for multiple things. And goal width governs precision. Next slide. So once we define those, we then actually can use much simpler language to describe the specification and the functionality required for the systems that are compatible with MLR search. So here, a search goal suddenly becomes a composite of multiple attributes that basically, and some of them, a number of them are required, some of them are optional, and right now we only have one optional goal width. But we are looking for feedback from the group if there are other optional attributes that should be added to the specification. But the main ones that are required is the final trial duration sum, loss ratio, and exceed ratio. You will see how we illustrate the use of them in the following slide, specifically referring to the existing standards. And then we have the controller input part also in the definitions that is basically a list of search goal instances. So this is what the operators provides as a configuration for the system. Next slide. So now let's look at I think a territory that everybody in this group should be comfortable with. So RFC 2544. So how is MLR search unconditionally compliant with RFC 2544? Well, it is enough by using this mandatory or required attributes in the search goal, to configure them as follows. The goal final trial duration is 60 seconds. Goal duration sum is 60 seconds, which means basically a single trial is the final trial at 60 seconds at the right load. The zero frame loss is basically expressed here as a goal loss ratio 0. And because we have a zero tolerance to any repeated trials or loss, then the goal exceed ratio is 0. And with those parameters set, the behavior of MLR search is the same as RFC 2544 binary search. Next slide. When we look at TST009, focusing on NFV benchmarking, work done by late Al Morton, a number of the teams from OPNFV in ETC, the team there recognized that there is a need to repeat trials in case there is a loss in some trials, and to make those results or measurements more repeatable and comparable. So in our case, to really be fully compatible, again, unconditionally with TST009, and so using as an example R equal 2, where R is basically a number of repeated trials, and in fact there is a bit of the typo here. It should say max R equal 2 as per quote in the footnote. We're setting the goal final trial duration to 60 seconds, goal duration sum to 120 seconds, and then goal ratio to 0, and then to be compliant with TST009, accepting one lossy trial, goal exceed ratio at 50%. With that, we are compliant with this. MLR search is compliant with TST009. Next slide. In terms of results, relevant upper bound, relevant lower bound. Really, what people will care about is the throughput. In our case, because we have set of conditions attached to the throughput, is a conditional throughput, and it's basically a forwarding rate at the relevant lower bound for the search, for a specific search. Next slide. So, yes, what are the results? So there's a goal result and a search result. So basically, it's a composite set of the results following a set of goals, and at the controller output is basically a composite equity of quantity of the two. Next slide. So in terms of the architecture, really, MLR search architecture consists of the three main components: manager, controller, measure. Measure does trials. Controller basically drives the measure and makes decisions about the loads and such, instructing the measure. And the manager is responsible for configuring the components, pre-configuring the environment, calling the controller with the configuration inputted by operator, and of course creating the test report. And the details are captured in the draft. So the final slide of the specification, next slide, is compliance. So when we're proposing that to make a networking measurement setup to be compliant with MLR search specification, it needs to contain the logical components as listed in the spec, so measure, controller, manager, and they have to be basically satisfying the requirements as specified in the draft. How the specifics of the implementation are out of scope for the draft, but the requirements on measure, controller, and manager are within the scope of the draft. And next slide. So with that work done at 07, I think we are in a position to state that the draft, in our review, is ready for a thorough review by the benchmarking working group, including any nitpicking, yeah, we would like to propose to go ahead with the last call, subject to any concerns. I think with the specification is, I think, the best we can produce. And if there is a further hardening required, we would appreciate the contribution and collaboration with a working group. One thing to say is that we developed this, and we've been collaborating in a working group focusing on software networking workloads and applications, but it equally applies to any networking devices, of course. And as highlighted in the previous slide, with specific configuration is fully compliant unconditionally with RFC 2544 and TSD 009. And there's one more slide just for reference. Giuseppe, if you could just one more. Some links. So we've been, MLR search has been in use in Linux Foundation networking in FDIO SysID project for multiple years now, and it's been over the last year or so, it's been stable. And we are currently benchmarking VPP, DPDK applications, and also T-Rex as a test generator itself. And the other reference is really here to highlight that just one of the recent publications that is focusing on software networking benchmarking in the cloud, in this case, and they are referring to FDIO, but they also, or the author of the GCP blog runs the benchmarking rig in the GCP cloud, and there is a recognition that there is a need for a benchmarking methodology suited for software networking. So with that, the final slide is a thank you slide, and I think I'm done and open to questions.
Thank you, Mashek. Yeah, any question? Maybe I can join the queue. Okay, I just want to say first thing as a chair, the next time please submit the draft in time with the submission cutoff of the IETF. On the other hand, as a participant, I just want to ask regarding the controller, because in the architecture there is a controller. Remind me, I didn't read the last version because you submit just a few days ago. It was too close to the meeting. For the controller, you don't suggest any specific technology. I mean, netconf, yang.
No,
So you leave it open to the implementation.
that's right.
Okay.
That's right. It's a pure separation of functionality to clearly delineate the responsibilities of different functional blocks of the system in terms of executing a trial, executing a set of trial to hit a certain goal, and making the load selection logic being in the manager, and in the controller, and so on. So there is no specific, the technologies itself and specific implementations are not really in scope. It's focused mainly on the logical functionality, logical blocks with associated functionality as defined in the draft, and we're trying to make those definitions formal, so not subject to interpretation, and as unambiguous as possible, if that makes sense.
Okay, thank you. Jean?
Yeah, Masik, actually, thank you for presentation. Actually, very impressive. You already implemented in the FADO, this kind of open source project. And I haven't read your detailed draft actually, but my question is, maybe related to the Giuseppe's question is about controller is, what is the scope of this job? Is focused on benchmarking methodology, or it's or you want to define some minimum architecture? Seems you introduce some controller. So whether this minimum architecture should be in the scope of this job, can you clarify a little bit?
Yeah, this is actually a very good question. The real reason why we introduced the architecture section is to clearly delineate the logical components and their functions within the MLR search methodology, and that is mainly for explanation reasons. Now, the text actually goes into the suggesting that the implementations may choose to merge those functions into under the different split as dictated. However, the way that we are specifying the requirements is based on those logical functional blocks, and if an implementer decides to implement it into the one functional block, but there is a clear delineation in terms of how those functions are implemented, then it is compliant. But it is questions like that we would like to really expose to the work group and make sure that the non-ambiguity that we're trying to reach is there, and we basically need more eyeballs and benchmark focus minds to make sure that this is clear, and if the language is also correct, so it's not confusing to anybody else. Yeah, I don't know whether, Bratko, you want to add more to this, because it is something I've been discussing for quite a bit.
Yeah, thank you for clarification. But for this memory architecture, I suggest maybe you can draw a figure to make it this more give the people the whole picture and easily understand how benchmarker methodology can be used in this kind of memory architecture.
Okay, we'll take the feedback. Thank you.
Okay, if there are no other comments, I just want to give a reply about the last call, the working group last call. I will discuss with Sarah, and maybe after the IETF meetings, we can follow up with you and with the group, so with the decision. But I think that it's quite stable, so maybe we can consider it.
Okay, Giuseppe, thank you very much. So be looking forward to hear from the chairs on the mailing list, and we take it from there. We are very eager, as we've been working on it for a while. We're very eager to progress this and also address any concerns, and also collaborate with the working group to harden the specification.
Okay, thank you, Marcia.
Thank you. Maybe Giuseppe, one more thing. We would really like to get feedback from the users, the testers, and so on, but also from the tester equipment vendors. I think there was a comment in one of the previous IETFs from Carsten Rosenhavel. It would be really good to get reviews from the testing vendors who are participating in BMWG. So we would really appreciate that. Thank you.
Okay, good. Okay, let's move to the next presentation. Vladimir, go ahead.
Hi, can you hear me?
Yeah, very good.
All right. So I'm ready for the next slide. Yes, so starting with the hackathon results, we did manage to synchronize the implementation with the latest modifications of the draft, and the changes which we didn't manage to make the last hackathon presentation were added and tested. We did make a sandbox device that we announced 4 days before today. So if anyone was interested to connect, it was possible to connect to the public IP address and with the credentials that we specified. And we posted a notification about this on the mailing list. So anyone who has some interoperability orchestrator could connect and validate that the device can actually send packets and receive them, and this can be done with their software. I don't think there was many that did. We saw 2 connections that were trying to configure something from the presentation. So this is like the example line that contains the credentials and the IP address, and that's what we sent to the mailing list. So if you go to the next slide, can I go to the next slide myself anyway?
Yeah, I can give you the control if you want.
Yeah, so without me interrupting you. Yeah, nice. So this is our setup. This is what we managed to get going, and we tried.
Just one thing, Vladimir. I see that you have 33 slides, so consider.
No, now this is containing some slides that were presented already, so we're not going to spend time on them. But there were some links that have been updated, so it's.
Yeah, consider that you have 10-15 minutes. So.
Yeah, it will be over in 5 minutes.
Okay,
so this is our setup. Nothing dramatic, just the minor changes that we had to validate. So I can go to the next slide. And this is a slide that we presented on the RIPE 88. We were allowed to present the work that is going in attempt to find interested operators, mostly because we know the equipment makers are a bit of reserved about new standard and new interface. They all have their proprietary interfaces, and we were hoping to get some interest in at the RIPE conference, and we did get some interest, and this is like what we had to get started there. So which 2 of the 5 network testers below have standard-based measurement interfaces and protocols. So this is like a good introduction, and that's what this work is all about. So I'll go to the next slide. Yes, so as you know, this is what we are focusing on, the network test management solution. And there are examples of existing solutions. As you know, you can configure test generators with command line interfaces, which are partially standardized, like the protocol is standardized there, but the commands themselves are not. So you have this 30 years old GPIB interface, and that's pretty much the only standard interface. Cisco has made some new ways to write tests with Cisco T-Rex and implemented. It's most of the people testing SDN are familiar with that. Keysight is a big player which has recently released this open traffic generator API based on REST. And some proprietary data models have been made open, but they're not based on YANC, especially the configuration is not based on YANC. And then you have Spirent, which made a significant work on the HLT API, which is very complex, very heavy API for writing almost anything. So there are also other interfaces which are existing. So we are doing this in YANC, and we're doing much simpler. If you compare with the focus on HLT API, for example, we are only focusing on what is minimalistic and allows you to do level 2, level 3 tests and nothing more specific and flexible. So I'll go to the next slide. Yeah, I added these 2 slides, a part of the RIPE conference, which contain a list of why I think this work is important. And this is like a test and measurement instrument automation wish list. This is like something that we have been thinking about for a long time before we submitted the drafts. If you have an interchangeable interface, something that you can change 2 different test equipment manufacturers and run the same code and get the same results. This doesn't exist today in networking. It exists in instrument though. It's like Ivy. If you know, if you have been using power supplies, oscilloscopes, and things like that, there is an Ivy interface which allows you to control 2 different instruments with the same interface. So we're just using YANC and netconf to do that same thing that measurement equipment vendors have been standardizing 20 years ago without using a programming language specific model. They are using program language specific model, so they are standardizing C++ classes, for example. And we're using YANC, which I believe is better, and it will pick up even in the measurement equipment device vendors. So the list is there. If anyone is interested in this, can check it and comment on the list if they don't agree with anything or they think something should be added. So yes, this is the second slide. And I added also 2 slides about the chronology of the evolution in the network test equipment standardization and implementations. So this starts from the 1965, where HP developed the first interface for configuring test instruments, and goes further into networking. The Internet Protocol is published, and yeah, it goes through Cisco that acquires TOF, and YANC becoming industry standard in networking. Yeah, it's the detailed list of what I think is relevant to this work that we're doing now. If someone is interested and wishes to comment on that, can send them to the mailing list. So this slide has been already presented. It just has updated links where needed, and some information is updated as well. So I'm not going to spend your time on that, but you know it's there and you can check it out. If you have been using any of the repositories, they have been changed. This is like probably the most concise implementation of a complete RFC 2544 benchmark. It's 407 lines of Python. So this can be a useful thing if someone is working in RFC 2544. It can check this implementation because it is really a proof that it is an elegant benchmark specification if it can really be implemented in 407 lines of Python code. And the code is based on the standard, the draft that we are working on to make a standard RFC. So it is probably the best thing to start if someone is considering reviewing the draft. So this like our report, partial report works from this command line. It's added for reference. This is the device that we are using. It is based on an open source FPGA and open source, even the enclosure is open source and published. Here is a quick reminder of the Young tree diagram, which we have presented already, just for reference for people who haven't been on the last session. This is more detailed view of the implementation in hardware to get that. And yeah, I think these slides have been presented on the last IETF session. I just left them so that we have a complete presentation that can be useful for someone who hasn't been following with the work during the last 4 years. So I'll just go quickly over that. We did some work on simulation, and this draft is very useful for simulating network devices because it is contrary to the other network programming interfaces for traffic generators. It is concentrating on just specifying the train with packets and not involving any protocol semantics. So firmware designer doesn't really care about the protocols. He just wants a sequence of packets and validate that his transceivers are not generating any bit errors. And we're not the only one who is doing that. Spirent is doing a collaboration effort with Cadence. So they have made a portion of their model, the proprietary interface they have integrated in Cadence. So it is an interesting side to have a standard way to write tests, because you can pre-silicon test the hardware that is being developed. And if it's in Young, it's even better, I think. So these are some slides just illustrating how we simulate and how we use netconf, communicating with simulated hardware to configure transactions and validate them. So that's all. We are looking for people that are interested in trying out this. If they're operators, it would be of interest. We are also interested, of course, with hardware vendors if they decide that they should introduce this new API as part of their products. And everyone who is experienced in testing can look through the draft and say if there is something missing. So in a conclusion, I just want to say that the draft has been stable. There have been a lot of things removed, and what is remaining seems to be what is the base. And we don't know if more is needed. If no one else finds use cases that are not supported, I guess this is ready for a last call, but it would be nice to wait a bit and find out more people that are actually using it and reviewing it, since there is no big hardware vendor that is behind the draft at this point.
Thank you, Vladimir. Any comments from the group? Yeah, please, Chin.
Hi, Vladimir. Long time no see. Yeah. So,
Hi.
I have known actually you have been doing this work for quite a long time. Actually, you mentioned Cisco, already support this kind of feature. I'm just wondering who will be the main consumer for this work? Or, is there any other vendor willing to, support this kind of work? Or also for like maybe there's some multi-vendor interoperability test they call the INTAG actually. There's a lot of tester company like Sprint or Keysight. So is there any this kind of player to really interested in this kind of work?
The like this industry standard companies producing test equipment 2 years ago were four. It was Teledyne, it was Xena for Denmark, Keysight and Spirent were the biggest. And now there are two because they bought each other. So now is Keysight and Teledyne remaining. And they have been working on this and they have very extensive models. For example, like this model that we are proposing is based on the Young configuration. They have been working on other approaches, and it is of their interest to keep their customers using their models, I guess. So they have not been into the discussion, although they have all the competence to improve that work. So if they join that work, it will be a much better draft. But there is significant difference between what they have and what we are proposing. We are abstracting away all the protocol details and allowing the user to use open source packet composers. Like there are open source packet composers that allow you to generate your packet, put it in that sequence that is going out, and not use any proprietary software to do that. And on the opposite, these companies have like extensive support for example, they have IPv4 and IPv6 and all the details that fall out of that. So they have introduced that as an integral part, even of the lowest levels. So in our model, you just specify the content of the packet, and you have the freedom to specify which fields of the packet are going to change, but you're not introducing any protocol semantics. So it is a draft that is much simpler, and it doesn't go obsolete if a new protocol is introduced. You just have to generate these templates yourself. So it's very much minimalistic, and it's something that should be of interest. But we haven't had any like direct input from these companies. So I wonder also if Keysight and Teledyne is willing to join this discussion. So your question, the answer is that they haven't said anything to us and they haven't commented anything on the IETF mailing list. So if you can generate interest and hear from them, that would be nice.
Thank you for clarification. I think, this company probably take a different approach. Yeah, but it seems your solution more compelling. Yeah, thank you.
Just one thing I wanted to mention, they have in the last 2 years, they have released the open interface. Keysight has released open API, and they have even included a Young model, which is only for reading status information. So I think they're looking at what is happening with this standardization effort, and they try to position themselves so that they are closer. They know the value of Young models, and they have introduced Young models for the first time. Last year happened that. So I'm also following what they're doing in their repositories. So if I see something useful that we don't have, I will definitely, if it's open and they declare it's no problem, I will propose it to the working group as well.
Yeah, thank you.
Thank you, Vladimir. Okay, let's continue the discussion on the list. And yeah, as you mentioned for the last call, we can wait a bit to have some more inputs, but of course you are next after the previous draft. Thank you, Vladimir.
Thank you.
Yeah, let's move to the next presentation. Mingong, okay. Yeah, hello, go ahead.
So good morning, everyone. My name is Minh Ngọc, and I present the consideration benchmarking network performance.
Speak closer to the mic.
Benchmarking in container infrastructure draft. Please go to the next slide. So quick introduction about the document again. So we have previous NFV benchmarking IFC. That's very much about the NFV, the IFC 8172 and 8204. The gap of these work as they haven't considered containerized infrastructure. So the scope of this document is to fill in the gaps of the previous work when applying to containerized NFV infrastructures. And the specific consideration gaps are the different network models and topologies configured by container network interface and resource configuration for containers. That's shown in the list below. Next slide, please. So this is the whole development of the draft. So it starts from 2019. And the first major update of the draft come in 2023. So we have received review from the Viper and GAP project from Linux Foundation. And we agree on 5 containerized network models and 4 resource configuration consideration. And the next one is on IETF 117. We update on based on the command in 116. So the major updates are the resource configuration benchmarking parameter are mentioned, and we remove the benchmarking appendix. And then on 118 meeting, then we once again update beyond the command in the working group. We provide a clear scope section, and we remove duplicate containerized infrastructure contents. And the draft is a job at the working group draft on 119. So the update here are the environment setup repeatability guidance for all container networking models. And since then, we in this version 1, it's just a minor editorial change. Next slide, please. So we in this meeting, we would like to call that if anyone have any suggestion or additional change for our working group draft, because we haven't received anything from since the previous time. And at this moment of as it did, I think that the draft is pretty quite stable and ready for the last call. So we would like to hear the comments from others.
Okay. Any question, comments, feedback? Yeah, I understand your point, and I try to push more reviews from the list in order to move this forward, because you also recap about the history of this draft. You made several hackathons, and so yeah. But yeah, we need more reviews and comments. Did you try to contact the authors of the other NFV related RFCs to see if they are willing to give some feedback?
We haven't tried that.
I mean,
The
the RFC 8172 and RFC 8204, maybe they can be interested to review.
No,
This is a first attempt to do a suggestion.
Yeah, I think we should do that.
Since they already working to related NFV RFC, so maybe they are willing to review this work as well.
Yes.
That's just a suggestion as a first step. But in any case, I will push the working group to review that. Chin.
Yeah,
Go ahead.
this is Chen Wu. I think in addition to use working group results, I think have you considered maybe propose some hackathon project to maybe introduce your project to get more maybe some feedback or comments to identify some issue, maybe operation issue or some other issue, and so maybe that's a good approach here. Have you considered it? Have a hackathon
I
project for
think we
that?
have done a lot of hackathon before.
Yeah,
the
they
first
already
upgrade.
did. If you look at this, the draft development,
It's have been for 4 years of hackathon before we finally have a review from the Linux Foundation.
Okay.
maybe you can, I don't know if it can be valuable to organize another hackathon for the next IETF to just to summarize the tests and to maybe to familiarize with more people and get more reviews. I don't know. It's maybe an additional suggestion.
Yeah, you should consider.
Yeah, you can consider, but in any case, you can also contact the other NFV related authors of the related RFCs to get some
Yes.
review. Okay, thank you. Let's move to the next. Paolo, yeah.
So, good morning, Paolo Volpato, Huawei. As usual, I'm presenting on behalf of the other authors you see listed here. So basically, this presentation is about has a scope of providing the update on our draft, which is for the benchmarking methodology for segment routing. So very quickly, where we are right now. Just to introduce the scope of the draft for those of you that maybe are not familiar, the scope deals with defining a standard method to benchmarking the segment routing packet forwarding capability of a network device. In doing that, we, let's say, rely on and extend the work done on the list of the RFCs listed here. So it's not just the scope of the benchmarking test, but also the benchmarking of specific capabilities, such as IPv6 or MPLS. Said that, probably you know that you're aware of the fact that the draft was adopted by benchmarking working group just after the past IETF. So first of all, thanks to all who supported the adoption. We received quite a good amount of comments and feedback, so we are quite happy about that. And you remember that the adoption took quite some time because there was a discussion whether to merge the two previous drafts. Maybe you remember there was one specific on segment routing MPLS and another one on SRv6. So after quite extensive discussion, we decided to merge the two of them. So basically, we are dealing now with just one single draft dealing with the benchmarking of both variants of segment routing. After adoption, we uploaded version 0.0, of course. That was back in June. And we also uploaded a new one. So we are discussing right now version 0.1 because we decided to deal with some remaining comments just after the previous ATF and in view of, let's say, ATF 120. So that this is the status. I would move to the next slide, please, Giuseppe. So what happened so far? Let's take a few minutes just to discuss the remaining comments, because I believe this is part of the work that we will do in the next few months before IETF 121. First, there is a remaining comment from Minok and also echoed by others. What about let's say, the testing of the compressed seed? So we are fully aware that this needs to be discussed in the draft. We have done a first analysis, which is not exhaustive, I would say, but just to, let's say, understand the amount of work to be done, we believe that it is not a complex task to introduce the discussion around compressed seed. But we need to touch every single test because we need to insert the specific description on what to do in case we have a compressed seed. So, as Edward, one of the co-authors, often says, it's like having a kind of third data plane in addition to SRMPLS and SRV6 to deal with. So we need to, again, review all the list of the tests and see how and where we need to introduce the discussion. As I said, for sure, this will be part of the next review. So for sure in Dublin at the IETF 121, we will discuss it. In any case, feel free to provide your view and your feedback on that. Then there is another comment which was raised by Louise. As you can imagine, we have internal discussions sometimes among the authors. Louise is also active with a draft in spring, which is about the security of SRV6. That is a personal draft. So for the moment, I would say, even if we will consider that as a source of input for our own, we have time to deal with that. In any case, the question was, is there anything concerning SRV6 security that we should also consider in our draft? Now, again, we have done a sort of a preliminary analysis. At the moment, our feeling is that the two drafts are sort of orthogonal. So we don't believe there is something that we should consider in the scope of the benchmarking of the forwarding capabilities of a network device. But we'd like to have your feedback. Maybe there is something that could be considered. We are not completely sure at this moment, as I said. And apart from that, there is a question that maybe I like to anticipate to the chairs and to the AED, which is sitting here. So it's something that we can maybe start discussing and then move on the list. In case we see there is something specific, some features, some capabilities associated with security, SRV6 security. So let's imagine that there is something, we are not sure, as I said. Something that we could consider for benchmarking. And we maybe identify the possibility of preparing a new draft, new contribution. Is security something that we can deal within benchmarking working group? So is it in scope? I'm just asking, there is no need to have the answer right now, but it's something that, the discussion triggered the question, so I'm pass on to you. Maybe it's something you can give us, let's say, recommendations or suggestions on how to move on.
Yeah,
Warren Kumari, Google. I mean, I don't know. It depends on what exactly you're asking. If it's doing benchmarking of the security part, like, can it do this number of packets per second when inspecting something, then that's probably in scope. But if it's like the security of, does it actually do what it says it does, or, the security of the benchmark itself, probably not. So,
right, okay. So I think we are aligned on that. Okay, next slide, please. Okay, then there is, let's say, the editorial review that we did in the past few weeks. So we had some refinement of the language. And while doing that review, there was also a doubt, let's say, that we shared once again in the group of authors, which is about fragmentation. Now, we tried to refine the language here, because there was a doubt, mainly raised by Louise and Bruno, again, moving back discussions from spring. So it is clear that for SRV6, we don't have a fragmentation. So the transit devices cannot do that. So that's clear. But the doubt triggered back, discussion, what about SR-MPLS? And in turn, that was about the fact that maybe an IPv4 packet could be carried by SRMPLS frame. So we discussed that internally, and at the end we specified, hopefully in a clear way, that fragmentation basically is not in scope of our draft in any case. So we're not considering fragmentation on IPv6 because that is forbidden by 8200, but at the same time, sorry, there is again the noise of the drill.
Closer to the mic.
Yeah,
The only
probably.
solution.
So we decided to specify that even for IPv4 packet carried on SRPLS, that is not in scope of the benchmarking test. So that maybe it's better I move to the conclusion of my presentation, because for the people on that are connected remotely, there is roadworks outside, so there is the noise of the drill. So next steps, as I said, for sure, we will discuss the compressed seed cases. That will be the subject of the next review. Then, this is once again a question that probably we will also forward on the list. We had private talks, basically, with people that told us some tests are ongoing using your draft, but those are private tests, so we cannot reference those tests in the draft. So if anyone is doing or performing some, let's say, publicly available or, let's say, activities that could be referenced in the draft, feel free to contact us. It's a reference we'd like to insert in the draft. And then for sure, the remaining next step, probably for the next IETF, we will try to cross-post the draft on the other two SRv6 related working groups, meaning Spring for sure, but also the new SRv6 Ops working group, because we believe that some of the experts in segment routing are there. So we'd like to start receiving also their feedback. So that, thank you again for supporting the adoption, and we are open to any questions.
Any comments, input?
Don't see any.
Yeah, if not, I just want to say, yeah, it makes sense to involve segment routing experts to review this draft, especially for the remaining open issues that there are in the draft. Yeah, speaking as also a co-author of that. Yeah.
Clear.
Okay, if there are no comments, we can move to
Thank
the next presentations. We have finished the working group documents. Yeah, we can move to Chin. Can you? Okay. Yeah, go ahead.
Morning, everyone. Actually, Carlos is not here, so on behalf of Carlos and other author, I will present this work. And this is not a new job. We already, it's the second time to present. And the title is Characterization and Benchmarking Methodology for Power in Networking Device. Next.
Okay, I can change because I didn't plug in.
Yeah, a little bit background capture actually, and as we know, we more focused on network operator networker. Currently in this networker, because of exposed growth of the network traffic and also some new technology should be used. So the equipment energy consumption is a big challenge actually. So in addition, actually, some of these energy consumption, to be consumed by equipment is unnecessary, is wasted. So therefore, more network operator, more thinking for the automation tools and solution to better assess and control the energy consumption for the larger network. And so we see actually technology trend is energy efficiency management, and this really allow network operator to optimize energy usage. And in addition, they can, improve the overall utilization. So the benchmarking methodology we proposed in this draft actually can be seen as important tools and can help a vendor to test energy efficiency for their devices. So this can be measured, for example, data traffic per unit energy consumption across the network. So in this draft, actually, we set several objectives. Actually, we more focused on objective 1 and also objective 2. And for objective 1, actually, usually, to assess, which part of the in the network, which network devices consume most energy, or which system can perform the best. So we can target to a set of well-defined scenario. For example, you can set some traffic load, with different traffic load, condition, and with some, temperature or some power setting. So you can test this kind of network device to see, which device can, perform the best, and or which device consume more energy. Second objective is try to measure the contribution of subsystem. This subsystem could be the component within the network device, for example, MPU, or the power module or optical module. So we can measure this component to the overall system, the energy efficiency performance. So in addition, actually, I think we also can cover the third objective to measure the contribution of the subsystem to the overall power consumption. In other words, we can measure the power proportion. So one of the example, we can report percentage of the power to be consumed by the, for example, power module or optical module, and so this give a sense of where to consume so much energy in the operator network. Next. So the document status update, and this is already present for a second time. Actually, previously we introduced this worker in IED environment workshop before the IETF 119, and we see a bunch of the comments, and also we presented in last IETF meeting, and thanks for all the commentator for the comments. Actually, we think very useful. For example, the Louis actually gave a suggestion. He think we should consider more realistic scenario. The current work we actually make some assumption. We just focus on to calculate the total installed capacity of the all interface. So this maybe not represent all the real deployment scenario. So we will cover more deployment scenario cases in the next version. And also during the environment impact workshop, in last IETF meeting, actually several suggestions also useful. For example, Torres suggested not only the mechanism we propose can be work for the router or switch, can be work for some other equipment like power distribution unit or some power supply actually. And Alex raised a very interesting question. It's ask us to consider how long it takes for transition from among different traffic load and level. So this is something we haven't thought through actually, whether we need to propose some new metric or we need to add some consideration to set some constraint how we can do the benchmarking test. And so for the latest version is 0.2. Actually, we make a minor update. For example, we add an ANA section, and we move a bunch of reference to the informative reference section. Also made some editorial change. And but the comments raised in the last time meeting, we think could be the good input and can be can be incorporated in the next version. But the current version actually we also believe actually is pretty much a good basis already actually. Next. Clarify a little bit of relationship with the green bulb deliverable. Actually, as we know, actually this IETF week we already have a green bulb and it goes well. And so this proposed green working group is targeted to explore the information to be exposed using young data models. So they cover two types of information. One is static capability parameters. So one of the example is we can, to model like the power interface static parameter, like nominal voltage or the power setting supported by power interface. But this is not in the scope for this benchmarking draft. And in addition, actually, in this young model also try to expose like a dynamic metric information. So typical example is the maximum throughput traffic load energy efficiency ratio. This is already covered by this benchmarking draft. And for some other useful metric, we actually discussed during the green bulb actually is about power usage effectiveness and core load factor, power factor that can be used in the data center network. And we think this is more focused on network level, not device level. So probably not in scope in this draft, but for the for third body actually we explore like a power gain energy proportion per component, more focused on the power proportion. Actually, the typical example, for example, power gain actually, this can be determined by by the actual power consumption divided by the maximum power consumption. So it's kind of device level metric. Another example about energy proportion is you can report the percentage of the optical module. We think this metric, could be be the new metric we can develop a benchmark method for. So actually in the green bulb green working group charter, it did describe some of collaboration effort. This green will collaborate with other working group that might have related work expertise with the defined standardized metric or measurement framework. So benchmarking working with has been listed one of the related working group could provide some of foundation or some kind of automation tool. This can be leveraged by Green to develop a young data model. But I think for Green working group, the young model, they focus actually not tied with these benchmarking work. They could report some real time metrics using some sensor to be installed on the specific component. So this the something we think it related to this benchmarking work. Next. For next step, we think this really provide useful automation tools and foundation for the green work can be further built on top of it and develop a young data model. And also I actually have some discussion with some expert from Intech actually actually they are very interested in this power benchmarking. They want to suggest maybe to have some multi-vendor interoperability test in the future. If we have this kind of work ready, actually I think we can encourage more vendor to to work together to perform this multi-vendor interoperability test during the Intech in the future. So we think this good basis already cover the basic metric related like energy efficient ratio at a device level, and but we do decide for some open question because we consider some new dynamic metric explored by the green working group. So we think some of these metric at a device level could be used for so we may consider actually maybe to consider the power gain, energy proportion per component, this kind of metric at a device level, so we can develop a benchmarking methodology for this metric. And probably this need to be rotated in the next version. So that's all from my side. Yeah, happy to take comments. Yeah.
Thank you, Chin. Any comment? Jan?
Yeah, Genshin from Huawei. So I have a question here. All this seems to be device level related, but there's also some energy efficiency related to infrastructure level. such as a power supply conversion unit from AC to DC, DC to AC, so on and so forth, and also for the air conditioner related to the infrastructure, there are also energy efficiency related. So will we cover this kind of features in the future?
Yeah, this good question. Actually, Torres also, have a similar comments. He think we not just limit to the router switch, in the operator network. We may covers, some other equipment type. Could be the, power distribution unit or HVAC related, equipment in the data center network. But if we, extend to explore at the device network level, I'm not sure in the scope of this benchmarking working group. Probably the chair can give some guidance on, because we're more focused on device level metric, right?
No, service is also in scope. So is also in scope
Okay.
in terms
So,
of benchmarking. Yeah.
yeah, probably. Yeah, I think we can consider, to this kind of network level metric, service level metric. Yeah. Thank you.
Yeah, I don't know if it can fit in one document, but let's think about
Yeah,
that.
yeah, sure. Actually, too many metric. Actually,
Yeah.
we need to consider how to, factor in or factor out. Yeah.
Any other comment? Yeah, I just want to thank you about the update also with relation with Greenboff. That was very successful. I also attended, and maybe we can, in the future discussion, it will be good to cross-post also the green mailing list for this draft to have some feedback from the experts that are there.
This could be useful, but do you think the green working group, we do have expert has some expertise? For example, IPPM, they may develop some new metric. Do you think they should also, post to the green?
For now,
working
in
group?
IPPM, there is no related to draft on metric. Maybe in the future there will be. So, in case, of course,
Yeah,
also
I
IPPM
agree.
as well.
I agree. Cross working group review will be helpful, but then I think this work not tied with green. This actually provides some useful tool, so the green working group can build on top of it.
Yeah,
So,
sure,
yeah.
sure. No, it's just to receive some feedback, some more feedback.
Yeah.
If in BMWG there is no expertise on that, so maybe there are some experts that are not aware of this work in BMWG, and it's good to be sure that they are aware and they can share their review. Yeah, it's just to a way to get more reviews.
Yeah, I agree. Actually, talking with Carlos and other problem, actually, they believe this already good basis for
Yeah.
adoption, and so, and I do agree. Actually, we need to have more eye on this draft to have cross review. Maybe not limit to the green, maybe RBPN working group, or maybe we can request some like a performance management director review, right? So this will be helpful. Yeah, thank you.
Thank you, Jin. So yeah. Let's move to the next. So yeah, let's continue the discussion on the main list for this doc. Xue Song.
Hi, Jason. Can you hear me well?
Yeah, go ahead.
Yeah, so will you help, to handle the slides?
Do you want the control? Yeah, I can pass you the control.
Yeah, I can try.
Yeah, please consider that we don't have so much time, so yeah.
Yeah, okay, I will make it very brief. Hi, this is Xue Song, and I will give a presentation about SRv6 service benchmarking guideline, representing other authors. Actually, this work has already been presented in last IETF, IETF 119, and after the presentation, we have received some feedback from the working group. And the most important thing is that there is an observation that in RFC 2544, it has already defined a number of tests to describe the performance characteristics of a network device, which is widely used for a single device. While when we look into the requirement from the service service provider and the vendors, we notice that besides the single device benchmarking, network level benchmarking is also very critical, especially the service provider can use it as a valuable reference point for on-net testing. And that is very essential for both service provider and vendor. So we are wondering whether it can be considered that similar tests and performance characteristics as it has already been defined in RFC 2544, like throughput, latency, and the packet loss rate could be defined for network level rather than only single device. I think there will be a lot of differences if we want to extend these benchmarking to network level. The most obvious one will be the topology. The typical topology for single device benchmarking is like the figure in the left hand. There will be a tester, there will be one device under test. But for the network level benchmarking, at least 3 devices should be considered under the test, and it will be a network that including PE nodes which connected to the tester directly, and also P node which connecting to PE nodes. So if we take SRA6 as an example, in the existing working group work, as Paulo has just presented, there is a very good base about SRA6 benchmarking for a single device. Although the document is not only for SRA6, but it have already gave a very detailed definition about the specific report parameters for SRA6. Including the number of segments considered in the seed list, and also the behaviors and flavors used for SRA6 tests. So, yeah.
Do you want to take a question now?
Yeah, sure.
Okay. Okay.
Yeah.
As you prefer, it's the same.
Warren Kamari, Google. I should probably have waited for the end for this, but you might want to also discuss some of this in the SRv6 ops working group. I mean, I know it is specifically about benchmarking, but because it involves more than just, a single device, having a good view of what all sort of environment should be considered might be useful, or what all deployment scenarios.
Yes, I think this is a very valuable comment. We will try to bring this work also to SRv6 Ops working group next time, maybe. Maybe after this presentation, we can bring it to the mailing list first.
Yeah, you can always cross-post both mailing lists, because
yes.
Of course, as also this also apply to the other document on segment routing. So since the expertise is in another working group, it is always good to involve the relevant experts that are supposed to be in that working group. Go ahead.
Yeah, okay. So based on the existing work about the single device benchmarking, we are trying to propose the benchmarking of SRv6 service capability, which means that different types of services could be transported through SRv6 network. If we take SRv6 as an example, the PE1 here can be used as SRv6 ingress node, and the PE2 here can be used as SRv6 egress node, and the P node here can be treated as SRv6 endpoint or transmit node. So because the SRv6 services can be divided into two classes basically. One is for best effort services and another for traffic engineering services. And for different type of services can be transported through the SRv6 network, including the internet service, layer 3 service over SRv6, also EVPN service over SRv6. So all these different scenarios can be considered in the topology, which we have just shown. Actually, we have already bring this discussion into the main list. We also have received some good feedback. If a working group think this is the right direction, in the next version, we plan to end this test topology with multiple nodes into our document and also bring the existing performance characteristics parameters have been defined in RFC 2544. Try to adjust the single device parameters into the next level benchmarking in this document. And also we are looking for more feedback from the working group.
Thank you, Shuesong. So yeah, any comments? Go ahead.
Yeah, again from Huawei, I have a quick question here. So my question is that what makes it different considering the network level comparing with the device level test? What decides if there's multiple devices across what decides the final results beyond the device level capabilities?
As I have mentioned, the most significant difference is about the test topology, because it will be much more complex to consider multiple nodes in one test. And the example I have raised in the previous slides is just includes 3 nodes, but that is the most simple case, especially for some other complex case. For example, the protection, more PE nodes will be considered in that scenario. So for this more complex test scenario, then the parameters, the definition of the parameters or the metric for the benchmarking should also be, redefined compared to the, the parameters only for one device. So considering all these aspects, we think maybe for the service or next or network level benchmarking, we need something new rather than just reuse the existing mechanisms that have already been defined.
Okay, thank you. Let's continue the discussion on the list and on SRv6 ops.
Yeah, sure.
Yeah.
Thanks.
Thank you.
Thanks.
Libin?
Yeah, I'm online.
Just
can you hear me?
Yeah, we can hear you. Just one point. Since you are the last one, but then we have also an invited speaker. Can you please introduce your draft in 5 minutes? So
Sure. I will make it as soon as possible.
Because I noticed that you have more than 10 slides, so just to make sure that you will focus on the important messages.
Sure.
Thank you.
Sure. Can I control slides by myself?
Yeah, I can pass the control to you.
Okay, sure. I can make it. Okay, good morning, everyone. I'm Li Binliu from Zhongguancun Lab. Today I will present a new draft benchmarking methodology for source address validation. So I will introduce the draft in the following 7 aspects. Okay, so let's quickly review the background of the draft. as we know that attacks based on source address spoofing, such as reflective DDoS and farting attacks, continue to present significant challenges to internet security. So mitigating these attacks in intradomain and interdomain networks requires effective source address validation. And BCP 8.4 proposes some solve solutions, such as ACL-based ingress filtering and URPF-based solve mechanisms. And the operators are suggested to deploy these solve mechanisms based on their network scenarios. Also, the intradomain and the interdomain subnet mechanisms are proposed in the subnet work group to solve existing problems of the solve mechanisms in validation accuracy and operational overhead. For this draft, the motivation is that proposing a standard benchmarking methodology is important for evaluating the performance of intradomain and interdomain solve mechanism fairly. For network operators, the benchmarking methodology can help them to get a more accurate idea about the performance of the solve devices in their deployed network environments. And for device vendors, the benchmarking methodology can help vendors test the performance of their solve implementations. And also the benchmarking methodology can guide how to evaluate whether the new intradomain and interdomain solve mechanism can satisfy the design requirements proposed in the intradomain and the interdomain subnet problem statement draft. Also, there are two objectives of this benchmarking methodology, including assessing which solve mechanism perform best and measuring the contribution of subsystems or solve systems. For the solve device under test, the benchmark aims to test the performance of individual solve devices, including the hardware or software routers. So for the test methodology, the DOT is connected to other network devices to construct a network topology. Since the location where the DOT resides in the topology affects the solve accuracy. And the tester can be connected to the DOT directly or by other devices. And it can generate traffic to test the solve accuracy, control plane, and data plane performance. And also the network traffic generated by a tester should specify the traffic rate, the proportion of spoofing and the legitimate traffic and distribution of source addresses. Also, the device in the network topology can have various routing configurations, and the generated solve rules of the device or the DOT is also affected by the configurations of the other devices in the topology. Also, we have proposed 6 solve performance indicators, including the proportion of improper blocks, proportion of improper commits, and the protocol convergence time, and the protocol speaking agent processing throughput, and the data plane solve table refreshing rate, and the data plane forwarding rate. And this draft proposed the benchmarking tests to test the intradomain and the interdomain solve mechanisms in terms of solve accuracy, control plane performance, and the data plane performance. And for this benchmarking test use different solve performance indicators as we pointed here. And for the solve accuracy of intradomain and interdomain solve mechanism, the objective is to measure the solve accuracy of the DOT to process legitimate and spoofing traffic in various intradomain and interdomain scenarios. We have listed the scenarios in detail in the draft. And for the interdomain solve, it includes the scenarios of solve for customer or host network, solve for internet-facing network, and solve for aggregation router-facing network. And for the interdomain networks, the scenarios include the solve for customer-facing AS and solve for provider or peer-facing AS. Here we list the 2 test cases for intradomain solve to test their solve accuracies. Actually, test case 1 and test case 2 form different scenarios. Test case 1 shows the intradomain symmetric routing scenario, and test case 2 shows the intradomain asymmetric routing scenarios. But for the detailed test cases, you can read a draft, or we can discuss it in the mailing list as well. And we also list the control plane performance and the data plane performance, test cases and test setups of the interdomain, interdomain sub. And we also define the objectives and how to test the data plane and the control plane performance, and how to calculate the self-information indicators, as well as protocol convergence perform time, and the protocol speaking agent processing throughput. And for the data plane performance, we also define how to calculate the data plane sub-table refreshing performance and the data plane forwarding performance as well. So also for the security considerations, we would like to test the DOT in a lab environment. The network is also the lab network is also isolated from the production network, to guarantee the test traffic will not be forwarded to the production network. Also, okay, we would like to seek feedback and comments from our work group, and also this is the version 00, and the collaborations are welcome. Okay, thank you very much.
Thank you. Thanks a lot for being quick. And thank you for introducing and for proposing this new draft in BMWG. Any quick comments? So if not, please review the draft and comment on the list. Thank you, Libin.
Thank you very much.
So now we have a presentation from Anna. This is not related to documents, but it may become a working group document, an IETF document. So Anna, please go ahead.
Hello. Hi, Giuseppe. Thank you very much. Hello, everyone. Should I introduce myself? I'm Anna Maria Mandolari, Assistant Professor at University College London. And since 2018, I work in Internet of Things, privacy and security, and in particular benchmarking privacy and security for Internet of Things. Today, I'm going to present a work that is going on since 3 years now. And hopefully, like Giuseppe said, this can become mostly today I'm going to present a problem statement more than a solution. And hopefully, as Giuseppe said, this can become a draft in the future. Do I have control on my slides? Or?
Yeah, I can pass you the control.
Thank you. Okay. So we know that any object nowadays can be connected to the internet from smart speakers, but also devices that we had in our cities. And the main problem is that these devices have sensors on them, so they can sense the environment. And most of the time, we saw that these devices are sending traffic across the internet, sometimes unencrypted. And for this reason, leave the users vulnerable. Not only this, but there are also concerns about privacy, destinations contacted by these devices, third-party tracking and advertisement. And in fact, nowadays, many regulators in many countries are establishing regulations and framework for studying these devices, and particularly try to contain the privacy and security issues that can come from them. At UCL, we have established one of the most advanced Internet of Things testbed in the world, and we have the same devices in also Imperial College and Imperial X, and there is a similar laboratory in Northeastern University in Boston that are our long-term collaborators. So this research started, as I said, in 2018. We bought hundreds of Internet of Things devices, and we tried to understand what are the privacy and security issues with them just by sniffing the network traffic. We have any kind of devices, from smart speakers to cameras, even fridges. And what we can do with this testbed is emulating the activity of the devices. So we sniff all the traffic from these devices, but we also test them in a way that we are able to trigger the activity through the companion apps of these devices in a completely automated way. And we're also able to emulate privacy and security attacks in a controlled environment. So we sniff all the traffic on the router. Well, in this case, is represented as a router, but in reality, it's a big server giving connectivity to all the devices, mostly Wi-Fi. But we also have some medical Internet of Things devices that are connected to the insulin pump, for example, or a mobile phone through other communication technology, like, for example, Bluetooth. So we are also able to sniff the traffic from Bluetooth in our testbed. One of the work that we did lately, so this is just an example, some examples of how we benchmark Internet of Things devices and some nice results that we had. Here you could see like how we tested smart televisions, for example, for a particular technology that came out in November 2023 that is called automated content recognition, for which smart televisions like Samsung or LG take screenshots of your screen every X milliseconds. So we were able in this case to emulate the usage of the television, watching videos for some time, and in the same time logging in and opting out to our television account or various privacy policies, for example, and then test what happened using the network traffic to the traffic of our televisions. We noticed that basically this kind of technology is not only used when you're watching some video, but also when you have the television connected via an HDMI cable, for example, that is a privacy concern. And most of the time we notice that this is not written in the privacy policy. So this is also another concerns. Another benchmarking tools that we developed in our testbed is benchmarking Internet of Things security safeguards. So there are a bunch of commercial devices that you can buy nowadays that claim to protect your smart devices in your home. And they claim to do any kind of activity from DOS attack recognition to open scanning attacks recognition, PII, personal identifiable information recognition, etc. We studied the methodology, so we implemented the methodology. This was a paper that has been accepted in one of the top security conference, and we were able to develop a methodology for which we could trigger the attacks from the IoT devices to the safeguards through this configuration that you see here in the figure. So we basically put the devices, then an IoT bridge between the devices and the safeguards, and then another IoT bridge gateway between the safeguards and the internet. We discovered that we can emulate in our testbed various security threats, network security threats, like, for example, anomalous behavior, open port, weak password, but also spoofing, device quarantine, DOS attacks, port scanning, and regarding privacy, DNS over HTTPS, testing DNS over HTTPS implementation, unencrypted traffic, or personal identifiable information exposure. This is just an example of one of the many methodologies we developed for testing these devices. So we usually have various steps. We simulate a threat, wait 20 minutes, check if the safeguards detect the threats, and then we repeat this 30 times. If at least one time the threat wasn't, if one time the threat was identified, then we say that the safeguards is able to detect the threat. So we put like a lower bound there. And this is just an example of the many emulations and methodologies that we use for testing, in this case, safeguards, but also for testing like the reaction and benchmarking Internet of Things devices themselves and then behavior against security attacks. Well, the results were interesting. We found that the majority of the safeguards are not actually doing what they're claiming in their web page. So they're, and we're talking about big tech company, like, for example, Bitdefender, F-Secure, Avira. We discovered that the majority of them are not actually able to detect the attacks, or if they do, it comes after like 3 minutes, sometimes 30 seconds. So when it's already too late. And this is why we are implementing a system that allow to do monitoring and benchmarking of Internet of Things devices in the home router. The motivation for this and the problem and the gap that we determined was that the majority of, so there are many nowadays cybersecurity guidelines, some requirements that are issued by the ENISA, by the NIST, regarding particularly Internet of Things devices, consumer in some cases, but we're talking also about Internet of Things devices in critical national infrastructure, like, for example, water control, etc. So in any country nowadays, we have a sort of regulations. These are like cybersecurity guidelines, but they are converted in regulation nowadays. In Europe, we will have in 2026 the Cyber Resilience Act and the NIS2. So all these regulations need to be enforced in some way, but also the developer, the manufacturer. Let's say, for example, a developer of a manufacturer of Internet of Things devices in Europe won't be able to sell the device in Europe if it's not certified against these Cyber Resilience Act requirements or any other GDPR in the case of privacy or any other cybersecurity regulations for digital services. So we developed a methodology that allow us to convert what are the requirements for the regulations and standards. But the main problem is that at the moment, regarding these regulations, particularly the Cyber Resilience Act in Europe, there are no standards. So this is the main gap that I wanted to highlight today with you, and then hopefully find a solution with this draft. So the idea is that you take the requirements from these regulations, and then you can turn them to some metrics that using the network traffic will be able to understand with active and passive tests. And I gave to you an example of the kind of tests that you can do for safeguards, for example, and then define experiments and tests to extract the metrics on Internet of Things devices. And in the end, you will produce a sort of certification of a sort of like attestation saying that the devices is actually required under the requirement of the Cyber Resilience Act or the regulations that we have. Just an example, we did like a super simple test in which we took some of the requirements under the Cyber Resilience Act, like number of unused ports, so any ports that is open needs to be used, or number of unrecognized protocols. And we saw that between all these devices that you can see here in this table, almost half of them are not compliant with the standard requirements. That is just one small requirement of a big regulation that is there. So we identify this gap basically, and we also have a methodology that allows us to understand if device is compliance with a requirement just looking at the response. So network traffic response from the active tests that we have. Using machine learning, we were able to train a model that looking at the response from the Internet of Things devices to reply attacks will tell us if the attack was successful or not, just to give you an example. So we can use actually machine learning for benchmarking Internet of Things devices, just looking at the network traffic. This is an example of how many devices in our lab with our methodology using machine learning for reply attacks were basically tested against reply attacks, and the attacks basically work. So in green, you can see for how many devices our reply attacks work, and there are many of them, over like 32 devices that we tested. So what's next? Hopefully a new draft on this, continuously doing tests in live on the home router or IoT gateway when we're talking about enterprise of a smart city is something that is needed, is crucial nowadays, because everybody know in this room that when an IoT device is as an upgrade, everything changes in the behavior of the network traffic from one day to another. And hopefully we can have what we call privacy and security label certifications and privacy and security score systems, for which using like standards and hopefully requirements that will be established in this working group, each devices will be certified and scored from A to F, for example, against the requirements and the standard of privacy and security issues for these devices. Thank you very much. Happy to take any comments, questions. This was just like a kickoff, hopefully a discussion that can go on for many more months.
Yeah, thanks a lot for the presentation, Anna. We have a comment from Chin. Any quick comment, because we already have finished of the session. So go ahead, quick.
Yeah, this is Qing from Huawei. So Anna, so it's thanks for presentation. Actually, very useful work. Actually, I'm not sure there's a relevant job already. Actually, but I see one question I have in mind is this related to the privacy security. You can provide a very useful tool for maybe regulator or some vendor. They can see how these can comply with the privacy or security. So it's a very useful tools and fit into the BMWG and could be have a draft to discuss this. But I feel the topic you bring actually maybe very broad actually because in IETF we have some IoT ops area actually. I'm not sure is any part can be break it down actually also write some draft to contribute to IoT ops. Also, I have a quick question. Have you been aware? Is there any other related SDO do the similar work, maybe in Dutch consortium? One in Dutch consortium have been aware, maybe highly related. What you are doing is IoT Security Foundation, and
the IoT Security Foundation in UK.
Yes.
I'm part of the. I'm part of the IoT Security Foundation. I'm part of the executive board.
Oh, so this is a part of this project?
No. This is a part of UCL, but I mean, this is just to say that I know very well the IoT Security Foundation. In fact, we are going to have a meeting in September at UCL talking about this. So this is a topic that is going on also in the IoT Security Foundation. But the IoT Security Foundation is very broad, so we're talking a lot there also about basically certifying the hardware more than looking at the communications for these devices. But just to tell you that I know very well the IoT Security Foundation. I'm also part of their board member.
Yeah,
the advisory board.
Yeah. I also see, maybe ETSR, there's some IoT related, maybe working group or maybe relevant. And if you can list several relevant standard body. Also, my suggestion is this will be the good topic, also discussed in the IoT ops. Yeah, because they do have a connection with IoT Security Foundation. Yeah.
Yeah.
Thank you.
Definitely.
Yeah, thank you, Chin.
Thank you.
Since we are already out of time, thank you again, Anna, for introducing very interesting presentation.
Thanks to you for the invitation.
Yeah, no, regarding, of course, the benchmarking part of the IoT, maybe this can be also in scope of BMWG. If the draft you have in mind have a broader scope, we can also involve IoT ops as well. This is just my comment because I don't know if Warren has some thoughts on that, but in any case, please, if you are interested, so reach out to Anna if you are interested to work on a new draft on moving this work forward in IETF. Reach out to Anna, and thank you again.
Thank you very much. So yeah, have a nice day. In my case, evening.
Yeah, have a nice evening.
Okay, thank you. Bye.
Bye. Okay, we reached the end of the session. So thank you, everyone. And please continue the discussion of the drafts on the mailing list and have a good rest of week in Vancouver. Bye-bye. See you in Dublin.